Hey YouTube, this is the second video in my series on my chess program, and this episode is going to be me walking you through the implementation, more specifically the implementation of the view. So just a quick overview of how the program's laid out. It's kind of a model view controller paradigm. But it's not exactly model view controller, because more of the way it's laid out is the view talks to a controller and the model talks to the controller, but the view and the model don't really know about each other. So if you look over here in my classes, I have these two packages. I have, well, besides all the resources, I have Tyrannus, and then I have Tyrannus.model. The .model stuff is, the idea is that all these classes are completely independent of platform and of implementation. So if I wanted to port this application to Android, I could keep all of these model classes exactly the same and then just write a new view and a controller on top of them. So that's the idea behind that separation. So let me go ahead and open up the BoardView class. I'm going to go ahead and run the program just so that you can see. So when I hit play, it loads a new game window class, and that game window has a big panel. The only thing in the window is actually a panel, and that is, the class is called BoardView.Java. So that's what this is that you're seeing. See the way it draws the green and it draws the yellow square around the piece, and the way it draws all the figurines. That's all in the BoardView class. So that's the thing we're going to be talking about today. The way it updates, draws the red. And here's a neat feature, how it's a darker red on the dark squares and a lighter red on the light squares. I'll show you how I was able to implement that. So let's get to it. BoardView.java, go over to the source panel, and okay, let's see how many. I'm going to walk you through 460 lines of code. Here we go. I have a bunch of private, static, final colors. Okay, so these are the idea behind having one for light color and dark color. These are just constants that can't change. The idea behind this is, if I wanted to change, right now the tiles are white and black, but if I wanted to change it to white and, let's say, gray or dark blue, I could easily do that without having to go through and retype it a million times. And ideally, once I implement all the reskinning options, the player will be able to open up a window and change the chess set and also all these colors. So I have all these trans. So trans stands for transparent. And what these colors are, so this is a red, and it's RGB, so 255, 255, 255. And then if this was a completely opaque red, that would be 255. But since it's 100, that means that it's partially transparent. So that's how I get the effects. I'm drawing these red tiles on top of the dark ones. So because it's not completely opaque, it's partially transparent, we're getting the effect of, you can still see the light and dark. And the same is true for the green and the blue. I haven't actually drawn any blue or gray or orange. Oh, I think I am using the gray. I'm using that for something else. It's been a long time since I looked at this class, but the blue is going to be used for a feature I want to implement later that shows which team is controlling which pieces of the board and how severely they're controlling it. So if you've got 4 pieces bearing down on a single tile, it's going to be really dark blue. Or if you only have 1 on it, it would be lighter. So that's the idea. That's what I'm going to use blue for. I hope it doesn't end up looking too much like a rainbow chessboard, but anyway. So I have all these buffered images, just speaks for themselves. I have ping files in my resources folder. Let's look at the black figurines. Yeah. So I have all these little files, and they look a lot better when I just open them in an image editor than they do in the program. I think that's because of Java's default scaling algorithms, and in the future I plan to implement my own scaling algorithms so that when they scale down they end up looking nice. I found a nice blog post on it by a guy. So I'll do an episode on how I managed to follow his directions and get a nicer scaled look so that my pieces don't look so jaggedy. Anyway, I have, well, let's keep looking at the piece images. So I have this static block, and of course it's all in a try block because when you load these ping files from these images from a file, you run the risk of course, asking for a file that doesn't exist. So you have to put it in a try block. And all this is doing is just reading all of these resources. And actually, it's not reading these ones. It's reading the ones from the resources folder. Yeah, see it right here. These. Anyway, moving on, we have, let's see, I skipped over a couple of these variables. Private set of coordinate legals, I'll get to that later. If you don't understand this syntax, that's how Java does generics. So you can just Google that and brush up on how generics work in Java. It was introduced in Java 1.5. So Boolean get a move false. That's an interesting story behind that variable and why it has to be there. And coordinate move start, move finish, previous start, pre-finish. So obviously the previous start and pre-finish, you can imagine what I'm using those for. That's so that I can color the previous move red. Move start and move finish. These are pretty simple variables. When, as I'll show you later, the mouse pressed method, when they press the mouse down, I store the location they clicked in move start. And when they release, I store it in move finish. Pretty simple. Okay, so frame length, grid length. Frame length is how large the actual window is, so that, right, so I'm just telling it that it's 600 because I know that it's 600 and I don't have it set to resizable, but ideally, once I do make it resizable, I'll just ask the window, the parent window, for the length of the view and set frame length equal to that. Grid length is, of course, the total length of the board divided by 8 because we have 8 slots in a board, vertically and horizontally. So this is just a method that sets the controller. Basically, all of the classes in this program have a private member game controller called controller. So it keeps it really neat for me. The reason that's not in the constructor is because it was giving me an annoying warning. And I don't remember what the warning was. But anyway. Okay, so all these buffered images I skipped over. These are layers, and this is how the view is drawn. If I can go to the paint component class. Paint component function. So basically I get a graphics 2D object of the... No, I just cast the graphics object. They pass into the method for you into a graphics 2D. And I just draw all these images, and the order matters. So first I draw the board. Then I draw the selection layer is where I have that yellow square around when you click a piece. Maybe I should have the program open. The illustration layer it's something it's something I've partially implemented. It takes effect when you right click, and the idea behind it is that you'd be able to right click to illustrate certain squares. See, you can see what it's doing there. Or click and drag to draw an arrow, things like that. So right now it just draws orange where I right click. If I keep right clicking, it draws darker orange. And of course, as soon as I click, it erases. So if someone wanted to make a screencast using the program and highlight certain pieces, they would be able to do that. So that's what the illustration layer is. Previous move layer, pretty simple. That's this red. So that's drawn in the previous move layer. If I were to comment out this line of code, you simply wouldn't get that layer. So it makes it pretty simple for if I wanted to turn that feature off, I could just say if is draw previous move layer. Or I would probably ask the controller for whether that box was checked, and then I would only draw the previous move layer if that was true. So that's the idea behind keeping all of this very separate and very manageable. Layers, I like the layers. Highlight layer, highlight layer is the yellow square. So what's selection layer? One of these probably isn't necessary. Well, I'm sure it is, I'm just forgetting. Oh, highlight layer is the, no, I already have a copy running. Stop. Highlight layer is the green. So the green tiles when I click on a piece and it gives me my optional moves. Those are drawn in the highlight layer. As you can see, all of these layers, the previous move layer doesn't, but the highlight layer clears as soon as you click somewhere else. Redraws. Coach layer, that's going to be, I kind of stole the term from Chessmaster, but they have their so-called chess coach that will draw certain things on the board to help you see. So that's the idea behind that. And figurine layer, of course, is where the pieces are drawn, and I draw those last so that, of course, you can see them on top of all the other stuff that I've drawn. So the figurine layer, that's pretty interesting. Let me go to, update. So this is image to draw. Okay, so this is a pretty big method. It does a lot, even though it's not too long. So this is the update. What it does is it updates the figurine layer based on a board object, and I'll get into the board object. That will probably take 3 videos to explain the entire board object. So what happens is we update. Okay, so we clear the figurine layer, of course, because we don't want to be drawing a whole new set of pieces on top of our old one every time we update. And rectangle direct. I should probably just make it rect. I don't know what I was thinking. Rectangle rect. Okay, buffered image to draw equals null. So, and we have 2 nested for loops, which you'll see all the time throughout this program, because of course we have a 2-dimensional array of 64 slots. So the way we iterate through it is we say, basically run this 8 times and run this 8 times. And what we do, I use I and J. I'm not sure I could use X and Y. I used I and J. But so we ask the board for the slot at this coordinate, and then we call this function get the rectangle at coordinate, which is the same coordinate, the one we're on. So we ask the board for the slot, and then we get the rectangle, and then we get the appropriate image. So get appropriate image returns one of these images, whether it's a light pawn, dark pawn, dark pawn. And the way we know what the appropriate image is because we ask the board. So when we get the slot object, we're learning what piece is actually on that slot in the model. And then what we do is we, based on what piece is on that slot, we get the appropriate image. So get appropriate image is just a long method that you can see here. Get appropriate image. It iterates through if type equals pawn. If it's white, return the light pawn image. If it's black, return the dark pawn image, which these should actually be white and black, not light and dark. But anyway, if it's a rook, return the light rook, dark rook. If it's bishop, white bishop, dark bishop. So that's what get appropriate image does. You just pass in a slot, or you pass in a piece object and it returns the appropriate image. Very convenient once it's written, but a pain to write. So if image to draw is not equal to null, which get appropriate image returns null if there is no piece on that square. So if there's no piece on there, do nothing. If there is a piece on that square, what's this? Oh yeah, this is just, I was drawing the pieces and they weren't centered in the tiles, so this is just shifting them. It's actually shifting them up 5 pixels because the Java coordinate system 0, 0 is actually in the very top left of the panel. Don't ask me why. So this is just shifting them up so that they look like they're in the middle of the square. Draw image into layer. So this is a nice function I have. You pass in a buffered image, which is the layer you want to draw into, a buffered image, which is the thing you want to draw, and a rectangle, which is where you want to draw it. So what this is doing is it's drawing the correct piece image into the figurine layer at the correct coordinate. So, and it does that 64 times for every slot on the board. So that is how we draw. That's how we draw the pieces. It's a mouthful. So paint component, we've done that. get grid coordinate from raw coordinate. This takes, so when I click somewhere on my program, of course it's 600 by 600. So let's say I were to click here. The point that's actually being received is something more like 400 by, I don't know, 350. So what this function does is it takes a point similar to 400, 350 and turns it into a point like, oh, did I really already quit out? Turns it into a point like 6.5. So it basically scales the coordinate system from out of 600 to out of 8, and it also rounds. So what it does is it takes this point, maybe 350, 200, and it converts it to 6, 4. So that's what that function does. Really convenient, because then I can call another function that says get rectangle at coordinate 6, 4, and what it does is it gives me this exact rectangle, and that's how this square is drawn. And I shouldn't have quit out. Get raw coordinate from grid coordinate. That's a function that I was about to implement, but then I didn't. I'll just get rid of it. So the Mouseclick function, I actually don't have much going on here, because Mouseclick, it only does something if it's a right click, and if it is, it draws the orange that I was showing you earlier. The most of the heavy lifting is in the mouse pressed and the mouse released methods, and of course mouse dragged. Fill rect with color in image. Okay, so as you can imagine, we're filling a certain rectangle, which is just x coordinate, y coordinate, a width and a height, with a certain color, and we're drawing it into a certain image. So if I want to draw a green square into the selection image at 3.5, I would just call, let me show how this function would be used. Fill rect with image, get rect at coordinate. So I can pass in a coordinate 5, 3. So I'll show you. I'll write this function, then I'll click the mouse. So get rect at coordinate 5, 3, color dot cyan layer I can't type illustration layer. So what this method will do is it's going to draw a cyan square at the coordinate 5, 3 when I click the mouse. There it is, 5, 3. So that's what function was that? Fill rect with color and image, which is a nice long function name, but that's what it does. Let's get rid of that before I forget. Highlight coordinate. It does the same thing as fill rect with color and image, but instead of asking for a color, it just goes ahead and... No, what does this function do? Get rect at coordinate, draw image. Oh, it just goes ahead and draws a green square into it. So that's for the highlight layer. All the possible moves are drawn in green. So instead of asking for a color, this one just goes ahead and colors it green. I technically don't need another function for that, but I have it. Get appropriate image, we've been over this. Highlight coordinates just runs the highlight coordinate function over a set of coordinates, so it iterates through them and highlights them all. Draw image into layer. So I've already shown what this function does. Here's its implementation. It's pretty basic. It gets a graphics 2D object from the first image you pass in, and it draws the thing you want to draw into it at the rectangle you told it to pass in, and it sets the image observer to itself, disposes of the graphics object, and calls repaint. Clear buffered image. This is a really convenient method. And I searched around on the internet for a while to find a decent way to clear a buffered image, and this is the best I got. So it gets a graphics handle of the image you pass in. It sets the composite to alpha. I'm not exactly sure what it does. I just found it. So it sets the color to completely transparent and no color, and it fills the whole image with it. Yeah, I'm not entirely sure what this line of code does, but I know it works. The mouse pressed function. I'll go ahead and cut the video off here, and then I'll get into how we actually listen for a move and get a move. So that'll be in the next video.